All right, guys. So good evening once again. We're still on matrices. And today we're going to be looking, well, we'll be continuing. So we're going to start off with transposition of matrices or transposing a matrix. All right, now from definition, we say when the rows of a matrix are interchanged with its columns, the matrix is said to be transposed. All right. So whatever the matrix has as rows, you're simply just going to turn them into columns. All right. So the symbol that we use to denote transpose. So if we have the matrix A, then A transpose is written with A to the capital T, right? So when you see this symbol, it means the transpose of the matrix A. All right, so so let's say that we have A being the matrix 3, 4, 5, 6. Then the transpose of the matrix A would be just to change the rows. And remember, the rows of A would be the ones that are going horizontally across. So that is one row. That is the second row. And so the first row becomes the first column in the transpose. So you just flip the rows into columns. So the first row becomes the first column. The second row becomes the second column. So once you write the rows as columns, then the matrix would now be transposed. Is that clear, guys? Raise your hand if you're understanding.
Can you repeat again for me, please?
So we're saying when you transpose a matrix, you change rows into columns. So whatever you had as rows, you turn them in the column form. So the rows go horizontal. So if you're changing it to column, you have to write it in the vertical form. So you have 3, 4 going across. When you write that as column, you're going to have 3, 4 coming down. So the first row of A, when you transpose the first row of A, you get the first column of the transpose. So the first row is 3, 4 across. So the first column of the transpose will be 3, 4 in the vertical form. The second row of the matrix A will now become the second column of the transpose of the matrix A. Is that clear now?
Yes, sir.
All right. What about you, Ms. Green? Is it clear to you?
Yes, sir.
All right. Okay, so diagonalizing a matrix. So we looked at how to transpose a matrix. Now we're going to look at how to diagonalize a matrix. Now, initially when we were looking at the types of matrices, if you can recall, we have what we call a diagonal matrix. Anybody remember what a diagonal matrix is? What are some of the properties of a diagonal matrix? Anybody?
Sir, my internet is giving trouble. Can you repeat, please?
So I was saying that earlier when we started matrices, we were looking at some types of matrices. And if you recall that I had noted one that we call a diagonal matrix.
Yes, sir.
Right. So I'm asking you now if you remember what a diagonal matrix look like. What
Yes.
it is.
Yes, sir. We have one number at the top left and one at the bottom right.
All right.
So,
it's
you understand what I'm saying, sir?
Yeah, man, I understand. So those would be,
You get what I'm saying, sir?
yeah, those would be the elements of the diagonal.
Yes, and then with the 0, 0. No,
Right.
no.
Right. So therefore then, a diagonal matrix is a matrix where the diagonal elements from the top left to the bottom right are non-zero elements and all the other elements are zeros, right? So all the other elements are zeros except for the diagonal elements. Is that clear, guys? Now, if we have a matrix, we should be able to diagonalize it, meaning that we want to convert a matrix into a diagonal form. In order to convert a matrix into a diagonal matrix, what we do, we have to multiply the matrix by what we call the adjoint of the matrix. So let us talk a little bit about the adjoint of the matrix A. So if you have the matrix A as A, B, C, D, then the adjoint of A, here we have A, D, J for a shortened form of adjoint. So the adjoint of A, we have to somewhat do some things to A to get the adjoint of A. So what we do for what we do to A, first what we do, we interchange the elements of the diagonal. So in other words, we switch these elements. So where the A would be, we interchange it with the D. So we switch them. So the A becomes D and the D becomes A. All right. Now the remaining elements, after we switch the diagonal elements, the remaining elements in the other, I would say, diagonal line would be B and C, but we don't interchange these, but instead we change the signs that they have. So that's how we get our adjoint matrix A. So just to walk you through that process again, to get adjoint A, we interchange the diagonal elements of A and change the signs of the other elements of A. Go ahead, Mr. Isom.
Oh, sorry, because I was about to ask you how you get the negative C and the negative B. So you said once we're doing the interchange, the left, the bottom left and the top right sign would change always.
Right.
And it has to be those elements.
So diagonal elements are interchanged and the signs of the other elements are changed to their opposite.
Yes, sir. But what I want to know also, it has to always be the bottom left and the top right.
Yes, because those are what we refer to as the diagonal elements.
Okay, sir.
Right, so from top left to bottom right, those are the elements that you interchange always. And then the signs of the others, you change them. So if you have positive, you change them to negative. If you have negative, you change them to positive and vice versa. Get the idea?
Sir.
So everybody get that idea, Miss Green, you get that idea?
Yes, sir.
Ms. Dorothy, I saw you came in a little late, but do you understand what we're doing? Are you hearing me, Miss Dorothy? Miss Cabrera?
Yes.
Are you following what I'm saying?
Yes, sir.
All right, so you understand how to
Yes,
adjoint of a matrix. So once you're given a matrix, to find its adjoint, you interchange these elements, which are the diagonal elements. So you just switch them around. So the A becomes D and the D becomes A. Switch them around. Then you change the signs of the remaining elements. And so you will get this matrix, which we refer to as the adjoint of the matrix A. All right, so once you have found the adjoint of the matrix A, once we multiply A times its adjoint, we are going to get a diagonalized matrix. And that's how we go about diagonalized matrix. So the matrix adj A is called the adjoint of the matrix A, or A adjoint. Note, the adjoint is found by interchanging the diagonal elements in A and changing the signs of the remaining elements. All right, so so the product of A times adjoint A will give you a diagonalized matrix. All right, so to find a diagonalized matrix, we multiply it by its adjoint matrix. All right, so example 1. So you're given the matrix A to be this, and they ask you to produce the diagonalized matrix, produce a diagonalized matrix from the matrix A. So what I'm going to ask you to do now is to find what adj A is for me, please. And then now raise your hand and tell me what's the adjoint of A. Go ahead, I'm giving you about 2 minutes, not so long. But
Sir, you mean just the set out, the other set out adjoint matrix?
just the adjoint, yes.
Okay.
All right, so what you get for the adjoint of A now?
Sir, that would be 1, 3
For the diagonal,
diagonal.
right?
Yes, sir, and then -2 and -5.
Correct. All right, so adj A would be that. Now, to find a diagonal matrix, then you would have to multiply A times the adjoint of A. Now, I'm going to ask you to multiply A times adj A, then raise your hand and give me the diagonal matrix that you find. All right, go ahead. I'll give you about 3 minutes to do that. You can lower your hand now, Ms. Lisa. All right, guys, go ahead and find the diagonal matrix for A. You may begin. All right, so Ms. Wilson, I see where you have your hand raised. That means you have found the diagonal matrix. Can you tell me what the diagonal matrix is, Ms. Wilson?
So I got minus, going across, -7 and -9, and then 0 and -7.
You mean -7 and -9, and then 0 and -7?
Yes, sir.
I think I need to check it again.
Okay.
Remember that you're getting a diagonal matrix. All right.
Okay, sir.
All right, what you got now, Ms. Wilson?
All right, -7, sir, 0, and then 0 and -7.
All right. Anybody else got that? Raise your hand, let me see. Miss Green, what you got?
Same thing, sir.
Dorothy?
Yes, sir. But I thought I did say it was a correct. That's why I'm not listening. I misplaced something else.
No, no, that's not what she said at first, you know. She started
Oh, okay.
-7, but I think she said something about -3 or something. Miss Cabrera?
Oh, Wi-Fi was acting up, so I just rejoined.
Okay, have you gotten a chance to multiply out the two matrices?
No.
All right. Well, you know what to do, right?
Yeah.
You're multiplying A times HA, and you should get a diagonal matrix. So when you're finished, let us know what you get, all right?
Yes.
All right. All right, so when you're multiplying matrices, it is important that you take into account whether or not you're pre-multiplying by a matrix or you're post-multiplying by a matrix. Anybody know what I mean by that? Pre-multiply or post-multiply?
So I know pre would be like the preparation and post is after.
Right, so if you are pre-multiplying by the adjoint, how would you do the arrangement?
By doing the layout, sir.
Right, how would you lay it out?
So the adjoint, sir, would have so you'd have A, which is right here. So that you'd keep the same 3, 2, and 5, 1, and then the second one now, so you have the 1 and the -2 and the -5 and the 3 in one bracket, right?
Right, but I was asking, suppose you were pre-multiplying by the adjoint, how would it be?
Oh, with the whole layout, sir. So that would be 3 times 1 plus 2 times -5. That way you're referring to?
I'm not really asking you to do the calculation. Just tell me how would you set out the two matrix? Which one you put down first and which one you put down next?
I put down the A first, sir, and then the A adjoint. That's what I did.
Yeah, but that's not pre-multiplying.
Oh.
And I'm trying to get you to understand the concept of pre-multiplying. So if you are pre-multiplying by the adjoint, then the adjoint would come first, then A would come after.
Oh.
This is now, you're putting A first and then timesing by the adjoint. That's post-multiplying by the adjoint. Now, pre and post-multiplying by a matrix is important because not all cases that, you remember that matrices are not commutative. So the order in which you multiply two matrices can really change the result. But for some matrices, you may see that the pre and the post multiplying will give you the same result. So in some cases, the commutative law holds, but in other cases, it does not. If you are multiplying a matrix by its inverse, and you know the inverse would be the identity, not the inverse, sorry, the identity matrix, I meant to say. Multiplying by the identity matrix, where you have the diagonal element would be 1s, and the other element would be 0. If you pre-multiply by it, or you post-multiply by it, you will still get back the same result. Right? So in that case, we know that matrix multiplication will be commutative. But wherever you find that two matrices have different numbers, or different matrices multiplying together, it's not usually the case that you will get the same result if you flip them around, changing the order, right? There are some instances that you may coincidentally get the same answer, but not in all cases. So that's something to bear in mind. All right, Ms. Cabrera, have you worked out what the result is supposed to be?
Yes, I got 7, then 0, then 0, then 7.
Is it positive 7 you got or negative 7?
-7.
All right. All right, so this is what you should get after you multiply 8 times its adjoint. All right. Now, finding the adjoint of a matrix can be very useful. One technique of solving simultaneous equation by matrices is to use the adjoint matrix. So that's one technique. Another technique that we use to solve simultaneous equation using matrices is finding the inverse of the matrix. So it's two methods that we can use, and we'll be seeing those shortly. All right, let us see if we can do another adjoint, another diagonal matrix. All right, from this one, produce the diagonal matrix for me, please, quickly. When you finish, raise your hands and then tell me what you get for your answer. Are you finished, Miss Wilson?
Yes, sir.
All right, give me a second, Miss Wilson. Let us hear what the others come up with. So give them a little time. Let's get started. Screen. All right, so let me check with Miss Darty first. Miss Darty, what did you get for your diagonal matrix?
Sorry, 6, -4, -2, and -1.
That's not the diagonal matrix, no, that's the adjoint matrix. What you got, Miss Wilson?
Sir, I got 6, +4, -2, and -1.
Right, but remember, I never asked you for the adjoint matrix. I asked you to produce the diagonal matrix. So I know you.
If we work out it.
Right, so you need to work it out and give me the diagonal matrix.
Okay, sir.
Not the adjoint matrix. You know how to find the adjoint already. All right, so go ahead, find the adjoint, multiply 8 times its adjoint, and tell me what the diagonal matrix is. Finish, Miss Wilson?
Yes, sir.
All right. All right, you can lower your hand. Let us give the others a little chance to finish. Waiting on the others. All right. All right, Ms. Cabrera is finished. What about you, Ms. Doherty? Are you finished?
Yes,
All right, Ms. Doherty, tell me what you got for the diagonal matrix.
so -1, -4, -2, and 6.
What is, you said -1, -4, -2, and 6. What is wrong with that, Ms. Doherty? Something is wrong with it. Tell me what is wrong with it. Remember, a diagonal matrix must have, the diagonal elements must be non-zero, or generally they are non-zero. And the other elements will be zero. So along the diagonal line, you should have non-zero elements. And across the other diagonal, you should have 0 elements. But your matrix have a lot of 0 elements. You notice? You notice